Dear student, welcome to the class. In the class, we are going to discuss one problem in eigenvalue and eigenvector. See, in the last class, we have discussed about that finding the eigenvalue and eigenvector of the 2 by 2 square matrix. Just we extend the problem. That is, we are going to find the eigenvalue and eigenvector of the 3 by 3 square matrix. Okay, see the problem. Find the eigenvalue and eigenvector of the matrix A equal to 1, 1, 3, 1, 5, 1, 3, 1, 1. How to write the solution? To find eigenvalue. Write the heading. To find eigenvalues. So to find the eigenvalue, first we have to write the characteristic equation. So what is the characteristic equation here? Lambda cube minus a1 lambda square plus a2 lambda minus a3 equal to 0. It is a common format for 3 by 3 matrix. So a1 is sum of diagonal elements of A. What are the sum of diagonal elements? 1 plus 5 plus 1. 1 plus 5 plus 1 is equal to 7. Second one is sum of the minus of diagonal elements of A. How to find that? How to find the minor for this of the diagonal element? What is the first diagonal element is 1. So you leave the respective column and the respective row. If you leave the respective row, respective column, so what you get? 5, 1, 1, 1. Second one diagonal element is 5. Leave the respective row, respective column. The remaining is 1, 3, 3, 1. Find the determinant of 1, 3, 3, 1. Right here. And then last one is the diagonal element. Leave the respective column, respective row. Then 1, 1, 1, 5. Find the determinant for this. So what you get? 5 minus 1 plus 1 minus 9 plus 5 minus 1. So that is equal to 0. A2 value is 0. A3 is determinant of A. How to find the determinant of A? 1 into 5 minus 1. Second one is put the minus here. So minus 1 and then 1 minus 3. So here minus 1, 1 minus 3 plus 3 into last one plus 3 into 1 minus 15. So if you are solving this, we will get the minus 36. So the characteristic equation is lambda cube minus 7 lambda square plus 36 equal to 0. How to solve this? To get the characteristic value or eigenvalue, so you have to solve the characteristic equation. You have to use the synthetic division method. This is one trial and error method. How to solve this? So here lambda cube, lambda square, lambda and a constant value is there. Write that lambda cube, lambda square, lambda, finally constant value is there. Write the respective coefficients. 1 minus 7, 1 minus 7, 0, 36. Now you take it this as A, B, C, D. This value as A, B, C, D. A, B, C, D. If A plus B plus C plus D equal to 0, if you are adding all the coefficients that is equal to 0, then the root is 1. And the root is, any one of the root is 1. Second one, in case A plus C equal to B plus D, that means if you are adding that alternate elements A plus C equal to B plus D, both are equal, then the root is minus 1. And the root is minus 1. Okay. Then how to solve this? We will see the step by step. first we have to try with, so in case if you are adding all the value a plus b plus c plus d equal to 0, are you getting a plus b plus c plus d equal to 0? No. Therefore, root 1 is not possible. Root 1 is not possible. It is ruled out. Leave it. Actually, it is a trial and error method. So, we have to try 1 minus 1, 2 minus 2, 3 minus 3 like that. So, when we go with that a plus second one, a plus c equal to b plus d. That means a plus c is what? A plus c is 1, b plus d is 36 minus 7. That is 29. So, both are not equal. Therefore, this is also not a root. Next, we try for 2. So, how to try 2? Put 2 here. Put 2 here. First, arbitrarily we put 0 here. We put 0 here. Adding this 1 and 0. Adding this 1 and 0. You will get 1. Add this. 1 and 0, 1. Then multiply that 2 into 1. We will get 2. We will get 2. Then adding this 2. Minus 7 plus 2. Minus 5. Now you are multiplying that with the 2. 2 into minus 5. Minus 10. Adding these two elements. Minus 10. And then multiplying 2 into minus 10. Minus 20. If you are getting that is equal to 0, then 2 is the root. Start from the beginning. In case if you are substituting, that means if you are finding that lambda equal to 2 as a root, first we put 2 here and then arbitrarily put 0 here. And then adding 1 and 0. Adding 1 and 0, you will get that is equal to 1. So adding, multiplying, adding, multiplying, adding, multiplying, you have to do alternately. So if you are adding that 1 and 0, 1, and then multiplying with 2 here, 2, and adding with that minus 7, you will get minus 5. Multiply with 2 here, and then it is minus 10. And then adding with 0 here, 0 minus 10, minus 10. Multiply the 2 into minus 10, minus 20, that is not equal to 0. Therefore, 2 is not the root. 2 is not the root. Therefore, we go for the next one option. What is the next option is minus 2. Next option is minus 2. Once again, we will do the same procedure. Once again, we will do the same procedure. Same procedure is what? First, we have to substitute, take 0 here. Arbitrarily take 0. And then adding this 2. 1 plus 0, 1. Multiply minus 2, 1. That is minus 2. Adding this 2. That is minus 9. Multiplying minus 2 into 10, 18. Adding 0 and 18, 18. Multiplying with minus 2, minus 36. So, if you are adding this two value, that is equal to 0. Therefore, if you are solving the cubic equation, you will get 3 roots now. Among the 3 roots, one root is minus 2. One root is minus 2. This method is called the synthetic division method. Okay. So once you find that lambda equal to minus 2, one of the root is lambda equal to minus 2. Next, we reduce one power here. This should be the coefficient of lambda square. This is the coefficient of lambda. It is a constant value. So therefore, this equation becomes lambda square minus 9 lambda plus 18 equal to 0. So solving this, minus b plus or minus root of b square minus 4ac by 2a. Okay, do that. What is minus b here? Plus 9 plus or minus square root of b square. B square is 81 minus 4ac. 4 into 18. 4 into 18 divided by 2 into a. A is 1 here. Therefore, we will get that 9 plus or minus square root of 81 minus 72 by 2. So 9 plus or minus square root of 9 by 2. That is 9 plus 9, 9 plus or minus 3 by 2. So that means 9 plus 3 by 2, comma 9 minus 3 by 2. 9 plus 3 by 2 is 12 by 2, that means 6, and then 9 minus 6 by 2, 3. Therefore, the eigenvalues of A are already we find minus 2 here. Already we found minus 2 here, minus 2, comma here we are finding the 3, comma 6. These are the eigenvalues of given matrix A. Next we are going to find that the eigenvectors of the matrix by using the eigenvalues minus 2, 3, 6. Next we are going to find that eigenvectors of the matrix. For the eigenvalues minus 2, 3, 6. How to find that? How to find the eigenvector? Write the heading to find eigenvector. In the equation you have to substitute lambda value. So 1 minus lambda 1, 3, 1, 5 minus lambda 1, 3, 1, 1 minus lambda. X is for 3 by 3 matrix, 3 unknowns are there, that is equal to 0. You have to substitute that lambda 1 by 1 in this equation. We get that one set of non-zero column matrix. That column matrix is known as the eigenvector. Case 1, you have to substitute lambda equal to minus 2 in this equation. We will get that 1 minus of minus 2 is 3, 1, 1, 3. Next one is 1. 5 minus minus 2 is 7, 1. Last one is 3, 1. 1 minus minus 2 is 3. X1, X2, X3 equal to 0, 0. Now multiply this 3x1 plus x2 plus 3x3 equal to 0. Second one is 3x1 plus 7x2 plus x3 equal to 0. Actually it is not 3, it is 1. Second one is x1. Third one is 3x1 plus x2 plus 3x3 equal to 0. So when we are solving these three equations, we will get the value of x1, x2, x3. Now one shortcut method is there to find that x1, x2, x3. How to find that? x1, x2, x3. Right? Take any two rows. That should be the distinct row. See that first row and the third row. First row and third row are the equal. Don't take like this. And then take the two distinct rows. 3, 1, 3, 1, 7, 1. 3, 1, 3, 1, 7, 1. Write this. Next we write that x1, x2. You have to write 5 columns. You have to write 5 values x1, x2, x3. Once again you have to write x1, x2. So what are the respective x1, x2? 3, 1, 1, 7. How to find x1, x2, x3? x1 is leave the respective column and then take the next two values. Next two values are x2, x3. You find the determinant of this matrix, this 2 by 2 matrix. Determinant of 2 by 2 matrix is 1 minus 21. 1 minus 21. Put x equal, then x2. To find the x2 value, you leave that the respective column, then you take the next two values. You take the next two values. Next two values are, you will find the determinant of this 3 minus 3. That is equal to, write x3. Similarly, to find x3, give the respective column, find the determinant of these two columns. So here 21 minus 1. How to write that? From the matrix, in the matrix, after applying that value of lambda, you take any two distinct row, and then you have to write 5 values, x1, x2, x3, once again x1, x2. Write the respective values 3, 1, 1, 7, 3, 1. So here 3, 1, 1, 7, 3, 1. Once again x1 value 3, 1, x2 value 1, 7. First you have to write the x1 value. To find the x1 value, leave the first column and take the determinant of these two rows, that means 1 minus 21. Similarly, write equal to x2. To find x2, leave the respective column. Then you have to find the determinant of these two values, that means 3 minus 3. Then finally x3. To find x3 value, you leave otherwise you strike out the respective column in the pencil. Then you have to find the determinant of this 2 by 2 matrix. That is 21 minus 1. So what you get? x1 by minus 20, x2 by 0, x3 by 20. That meaning is x1 is, so it is in the ratio minus 20, 0, 20. This can be written as x1 by minus 1, x2 by 0, x3 by plus 1. So we can write the respective eigenvector is x. We can write the first eigenvector is x1 minus 1, 0, 1. It is one ratio. Otherwise we can write this as 1, 0, 1, 0, minus 1. Similarly, we can find the next two eigen vectors for that lambda equal to 3 and 6. Our next case is lambda equal to 3. Substitute lambda equal to 3 in this equation. We will get that 1 minus 3 is minus 2. Remaining is 1, 3. Can write as it is 1. 5 minus 3 is 2 and then 1. Final one is 3, 1. 1 minus 3 is minus 2. Then x1, x2, x3 write that equal to 0. So multiplying that you will get that minus 2x1 plus x2 plus x3 equal to 0. x1 plus 2x2 plus x3 equal to 0. 3x1 plus x2 minus 2x3 equal to 0. Solving these three equations, we will get x1, x2, x3. Otherwise, we have to write like this: x1, x2, x3, x1, x2 continuously 5 columns. You take any 2 rows, either this 2 or this 2 or this 2, 1 and 2 or 2 and 3 or 1 and 3. Any 2 rows, you should not take the identical rows. You have to take the different rows only, different values rows. So minus 2, 1, 3. See that? Minus 2, 1, 3, minus 2, 1. You can use the same procedure to find the value of x1, x2, x3 for this 2 row. This 2 row. You can try that. You will get the same answer. So second one row is 1, 2, 1. See that? 1, 2, 1. Once again write 1, 2. To find x1, you strike out that x1 value. That is, you strike out the x1 value. Then you find the determinant of next to 2 columns. So next to 2 columns is, see that, 1 minus 6. You have to write. Similarly, to find the x2 value, leave the respective column. You find the determinant of next to 2 column. That is 3 minus 2, 1, 1. That means 3 plus 2. Similarly for x3, to find x3 value, you strike out that x3, then take the determinant of these 2 values. That means minus 4, minus 1. Minus 4, minus 1. That is minus 5. So x1, x2, x3 is minus 5, 5, minus 5. So it is in the ratio of either 1 minus 1, 1, or you multiply with minus in all the value, minus 1, 1, minus 1. So what is the eigenvector for lambda equal to 3? For lambda equal to 3, the eigenvector is 1 minus 1, 1, or minus 1, 1, minus 1. Final case is, last case, case 3, lambda equal to 6. For lambda equal to 6, substitute that lambda equal to 6 here. 1 minus 6 is minus 5. Minus 5, 1, 3. 1 minus 1, 1. And 3, 1, minus 5. You will get the matrix. Then non-zero column matrix x1, x2, x3, that is equal to 0. We have to use the same procedure. Write the 5 columns x1, x2, x3, x1, x2. Take any 2 rows. Minus 5, 1, 3. So see that, minus 5, 1, 3, and then minus 5, 1. Once again write the 2 value. Here the second one is 1 minus 1, 1. Here you write that 1 minus 1, 1. Once again write that 1 minus 1. To find the x1 value, you hide that first one, x1, take the determinant of next 2 values. That means 1 minus 3. 1 minus 3, 1 plus 3. 1 plus 3 is 4. For x2, x2 is, to find x2, you leave this column, find the determinant of these 2 columns. That means 3 plus 5. 3 plus 5 is 8. To find x3, you leave this column and then find the determinant of next to 2 column, and 5 minus 1. Now 1 plus 3 is 4. 3 plus 5 is 4. 5 minus 1 is 4. Therefore x3 is 4, 8, 4, or it is in the ratio of 1 to 1. So this is the procedure to find the eigenvalue and eigenvector of the 3 by 3 matrix. In the next class, we will discuss one more problem. Thank you.